Hi, my name is Clint Wyckoff, and I'm an enterprise support manager at AWS based out of Pittsburgh, Pennsylvania. Thanks for joining us today, and welcome to AWS Supports You, where we share best practices and troubleshooting tips from AWS support. Joining me today is Mike Wells and Aiden Beckeroff from AWS Support. Guys, can you give us a quick introduction?
Yeah, sure. I'm Mike Wells, a senior technical account manager with AWS, and I support customers with operations, cost optimization, and navigating the AWS ecosphere. I've had several customers make the switch to Graviton2, and I'm excited to talk to you about it today. Aiden?
Hey, I'm Aiden. I'm an enterprise support lead based in California, and always glad to share ways to help customers improve costs, performance, security on the cloud, and Graviton2 has been a big part of that lately. So yeah, happy to dive in.
Perfect, guys. Thanks for being here today. And as you mentioned, we're going to be talking about Graviton2, specifically moving your databases over to Graviton2. And we're going to specifically focus on performance and the cost related to that move, right? And before we get into the details, a quick note to our attendees online. Feel free to use the chat window on the right-hand side of the screen. And also let us know where you're joining us from today and share your thoughts and questions throughout the episode. We look forward to hearing from you. Aiden, let's kick it off. And can you walk us through what we're going to be talking about today?
Yeah, Clint. So we'll go over some background on Graviton2 and just how straightforward it is to migrate and adopt it. And we'll also cover the exact benefits and steps to migrate, Amazon RDS and Aurora to Graviton2 and get those benefits. And lastly, we'll have a demo of actually migrating, cutting over, and benchmarking the differences between previous generation instances and current Graviton2 instances for RDS. Yeah. So, what is Graviton2 processors? What are we dealing with here? So Graviton family of processors are our own custom built and designed silicon. And we designed them to push the price performance benefits of a broad range of cloud workloads for our customers. So we now have thousands and thousands of customers who have significant price performance benefits because of the Graviton2 based instances, and in turn can build and innovate faster and more cost effectively to delight their own customers. So, what exactly are the components of the Graviton2 processor? Let's jump in and take a look. First and foremost, we have the actual processor itself, right, which is built on 7-nanometer custom silicon and offers just exceptional performance. However, Graviton2 is not the first nor the only piece of custom silicon powering, Amazon EC2. We have the Nitro security chip that's integrated into the motherboards, and that protects and monitors hardware resources. We also have the Nitro card itself, which unloads many of the traditional needs of the hypervisor into bespoke hardware, like essentially allowing much better performance with a lighter footprint. And the Nitro card handles interfacing with devices like Amazon EBS or Amazon ENA, their network attachments, and also provides additional monitoring and security for those interfaces. And finally, because of the Nitro security chip and the Nitro card, the Nitro hypervisor itself is very lightweight. It handles memory and CPU allocation like with bare metal-like performance. So these purpose-built and modular building blocks, give Graviton2 based instances like tremendous performance. And yeah, if you're interested more in Nitro, we can drop a really cool reInvent talk from 2019, diving deep into Nitro there. But yeah, any questions at this point? All right, let's jump in then to the managed services side of it. We're going to be focusing a little more on that this talk today. So here's 12 different services already that are supporting managed services, and we can drop a link of more details on how to get going on diving into some of these services here. And essentially we've extended the price performance benefits of Graviton2 into these managed services. Important ones we'll be talking about today will be Amazon Aurora and RDS, but there's also DocumentDB, Elasticache, MemoryDB, OpenSearch, etc. And we're announcing more and more all the time. We've got 4 new ones here just from the last few months, and in addition, many more services like EKS and ECS also support Graviton2 based instances. So yeah, and we're happy to keep supporting them and growing the capabilities that's supported here. So yeah, Clint, do we have any questions on that? It's 12 different services there, so different capabilities.
No questions so far. I'm looking good.
All right. Well, just some background here is, with the success of the Graviton 1, the A1 instance families that we launched in reInvent 2018, we wanted to, which was great really for web and gaming servers, for example, we wanted to broaden the workloads and target many different applications for Graviton, right? And especially in workloads like, high performance computing, media encoding, in-memory caches, EDA, that's electronic design automation, that we ourselves use to design the processors. That's where, the growing spectrum of workloads has really helped us. So in reInvent 2019, we launched Graviton2 that improved performance and opened up the playing field for a lot of different extra workloads. And today we're going to be focusing on critical workloads run on open source databases like MySQL, Postgres, and MariaDB. So just a quick refresher, Amazon RDS is our managed relational database service, and it makes it easy to set up, operate, scale a relational database in the cloud, and automating time-consuming admin tasks like hardware provisioning, database setups, patching, and backups. And Aurora, very similar benefits, but it allows for even greater scaling by decoupling compute and storage. Way higher limits for read replicas and total database size. So yeah, just a bit of background there. Good stuff. Well, let me pause there and just make sure we got no questions.
Yeah, hey, so we did get a question from JibJab06, and his question was, earlier you had mentioned Nitro. We're unfamiliar with that. So can you explain to the audience what is Nitro?
Yes, totally. So Nitro is our purpose-built system that handles this whole ecosystem of all of our new generation instances are built on the Nitro platform. That means we're going to have like the Nitro security chip, the Nitro card, and the Nitro hypervisor itself. So this is what you'll find on newer generation instances. And for a really cool deep dive, there's that reInvent 2019 talk on the whole Nitro system, if you're interested in digging into that.
Yep, and I did drop a link to that in the chat there.
Cool. So, Mike, why and how should we upgrade our totally good RDS and Aurora instances?
I'm glad you asked, Aiden. These Graviton2 instances for RDS and Aurora, for RDS specifically, give 52% better price performance against the previous generation of instances in RDS. And for Aurora, you can expect around 35% better price performance. Upgrading allows customers to get higher EBS and network bandwidth with just a few clicks in the console to be able to do this upgrade. The path to upgrade is really, really simple, and we'll show it in our demo today. And all the existing RDS features are supported in Graviton as well. You can mix and match in Aurora and be able to use different classes in Aurora. And this is available for Aurora MySQL, Aurora PostgreSQL, RDS PostgreSQL, RDS MySQL, and RDS MariaDB. A little bit about how this works. Graviton2 is actually able to achieve greater performance at lower cost. On the top left in this slide, you can see the new R6G Graviton CPU. And because each Graviton2 vCPU is actually a physical core, not a shared hyperthread like the vPCU on the right, you have access to the full resources. And at the bottom for Graviton2, there's only one socket on each Graviton2 motherboard, and all memory access is local as compared to non-Graviton instances such as R5, where there are two sockets. And in many cases, the memory is accessed from the second socket, which creates a non-uniform memory access, which may create a little delay and a small performance hit. These architectural improvements result in a real performance advantage in managed database workloads. Another oft overlooked aspect of this is the CPU power efficiency, and the performance per watt is something that we look for better sustainability. A higher performance to watt ratio means higher density, it means less cooling needs and smaller space needs, and that results in cost that we pass through. And all of this translates into a lower carbon footprint as well and greater sustainability. As we all know, or maybe you have or have not seen, we introduced the new sustainability tier to the as a well-architected pillar. And we launched this in reInvent in 2021. And you should definitely check it out and consider it for your new workloads, this new sustainability pillar. The types of instances that we support, here is a list. These are the instance details supported today, and these are the largest instance sizes below for each instance family. And I'll explain what workloads suit best for each of these in just a minute. Some call outs, you'll see that RDS has an extra instance family supported, the M6G, and also that the X2G has over 1 terabyte with a T of memory. And that's 19 gigabytes per second throughput on the M, R, and X families. And compute power is the same with 64 vCPU for the M, R, and X2. But you'll notice more memory. You'll notice that the memory increases over 4 times for workloads with higher in-memory requirements. Any questions in the chat currently about these?
So, hey, Mike. So there hasn't been any questions in the chat, but one did pop into my mind, if I may. Is AWS users and builders are looking to adopt Graviton. How easy is it them to refactor applications to support the new platform, since it is a different CPU type?
Yeah, so with RDS, it's a pretty much, they have parity between the two of them. So all the tools that you typically use are supported in Graviton, such as insights, performance insights. For other managed services that we have, for the most part, managed services move over one-to-one as well. We have for things where third-party applications are used, it depends on if they've been compiled for this architecture or not. That, it's pretty easy to move, and we're going to go through a demo here shortly to show that as well.
Right. So the big thing, though, from like an application perspective, is you always want to test first, and don't just
Totally
assume that that it worked on Intel or AMD, that it's going to work on Graviton.
Right. We highly recommend doing both performance and just sanity checks to be sure after you've moved that things are working correctly.
Perfect.
And stay on the latest versions wherever possible, latest operating systems, and that generally the newer you're working with, the better results you'll get. Even if it is compatible in an older version, you may get better performance on a newer version. So yeah, stay up to date.
Good tips. Yeah, so a bit about which instance types are best for what use cases, and also Graviton. I want to highlight this once more. Graviton2 instances can result in 35% better price performance for Aurora and 52 price performance ratio improvement for RDS open source databases, depending on the database engine, version, and workload. The best use case for these instance families, M6G, which is only available in RDS and not in Aurora today, is best for general purpose workloads. It's got just enough memory, not too much, not too little. R6Gs double the memory to 512 gigabytes. And T4s are best suited for dev, test, and generally burstable workloads. And lastly, the X2G is purpose-built for the memory-heavy workloads with a terabyte of memory. At the bottom here, there's a number of workshops to explore the differences further, and hopefully we can drop these into the link. I highly recommend going through these workshops and checking out how Graviton can work for you. All right, Aiden, you want to take over here and show us a little demo?
Yeah, Clint, unless we got any questions, we could kick off here and drop a link as well for anybody to follow this workshop. So, all right, let's jump into it then. So first and foremost, we're going to be benchmarking moving RDS Postgres from the previous generation M5 instance type to the M6G instance types. And here we're going to be benchmarking actually with HammerDB and running write-heavy and read-heavy workloads and having a look at the performance differences and comparing what our end results are going to be. And we're going to be running this, visually in the console here, but also in a IDE. So we'll be using the Cloud9 IDE that we set up in our prerequisites. And there's an easy CloudFormation template you can run and just get going, deploy the VPC settings and deploy a generic, I think it's a T3 instance type. What you'll want to do is upgrade that to a larger instance type. I upgraded it from a T3 to a M5. It's just a much larger instance there to make sure that when we're benchmarking it, we can give it the thousands of IOPS it needs to stress test it. So with that being said, jumping to the intermediate level workshop part here, you have some bit of background on what HammerDB is going to be giving us, how to actually go and what steps to run, what scripts to download. There's about 8 different shell scripts you're going to want to download and prep your Cloud9 IDE with. And there's a snapshot you can also copy over, which we'll get to save you some time instead of building the schemas yourself. So I've gone ahead and already deployed a x86-based Postgres database in US West 2B. You can see it's running the .m5 .large size. And jumping over to my Cloud9 IDE, right? It's just running on an EC2 instance. We can double check we're going to be hitting the right database. Yep, we're definitely targeting the x86 instance first. I've already gone ahead and run started the benchmarking from HammerDB because it runs for like 25 minutes in the default for the workshop. I'm going to be doing some video magic here to make sure that we can see the results instead of waiting 20 plus minutes for each database, but we'll let it run. And there's our number of different shell scripts on the left to the various versions of what we're looking at here. We're targeting the x86 database at the top, the second line there, and we've got the right settings there with AWS Secrets Manager. So we're not showing you username and passwords and other database secrets. And we'll let this run. As you can see, its CPU's at 99.87%. And if we look at some of the monitoring for this, we can make sure definitely it is taking a lot of load right now. So we're benchmarking this. This is for OLAP analytics processing workloads. So, excuse me. This one is the OLAP workload. So we're going to make sure we're going to get a lot of traffic on this instance, and we can refresh and have a look. Make sure it's still reading it. Okay, so we should jump to the end here and make sure. Okay, so our benchmark for the x86 instance is complete. We're going to harvest from the logs the results a little bit and compare them. But in the meantime, let's go ahead and actually create a read replica of this x86 instance and actually go ahead and show you how you can move to a different instance type. We're going to choose the same size, but from the M6G, the Graviton2 based instance. We're going to use the same settings, 5,000 provisioned IOPS, same network and security settings, and make sure everything's in the same configurations. And yep, perfect, same subnet groups, no changes here, all good. We're going to have to rename, give it a unique database identifier instance name, and we'll do -graviton, and no changes for database ports. Let's enable enhanced monitoring with 1 second granularity just to have a deep look while we're running the benchmark. And very good. Use the same monitoring IAM role. All right, logs look good. Perfect. So let's go ahead and create the read replica of this. And there's no need to run minor version upgrades right now as we're just benchmarking. So we'll let this create, refresh the page. And great, now it's going to take a few moments and we'll see it's modifying our primary database and creating our replica database. Let's just jump ahead. They're both now available. You'll see the role is primary and replica. And at this point, we're going to want to promote our Graviton read replica currently. And we'll go ahead and click continue. And this is a double check. It's warning us it will result in a reboot, and your database identifier name you'll have a new identifier name, and it's saying reduce traffic or cut off traffic before you do this as a warning. So take some precautions here, right? If this was a production database, that's what it's warning us. And we'll just promote our read replica. And again, give it about a few moments, refresh the page, and currently, okay, so it's modifying, great. The replica is now modifying, and we'll jump back when it's available. Awesome. So now we see at the top that the m6g.large has been promoted as a primary replica. And let's go ahead and kick off the exact same benchmarking from HammerDB. And just really briefly, I'm grabbing from the workshop, I'm grabbing the benchmarking configuration and pasting that in on my Cloud9 instance. This is the data warehouse workload, decision support tree workload. And that looks good to me. Let's go ahead and copy paste this. And we're going to have to, I'll leave the same configuration here. 1500 seconds is going to be about 20-25 minutes. 50 threads, 50 virtual users. So same load that we'll be putting on it as the previous x86 database. And just make sure we change the name to whatever we named that database to. Perfect, Graviton. And yep, that's the right name. Let's go ahead and save this and run this script, kick off this benchmark. Okay, cool. So we'll let this run for about 20-25 minutes, 1500 seconds, and double check that definitely we are getting load on this instance. Great, we can see the CPU ramping up. Current activity, 50+ sessions. Just jumping into the monitoring, if you remember, we enabled enhanced monitoring. So we can have a quick look at what enhanced monitoring looks like under the monitoring drop-down menu here. So we're seeing a lot of load, a lot of details. This is per second granularity, 100% vCPU usage. And load times, average load times, 5-15 minutes. Super. Yeah, definitely hammering the database here. And yeah, it's kicking off. So let's also have a look at another really cool performance insights from in your RDS console. This will tell you a lot of different details about exactly what your database is. For example, the write-ahead logs we're seeing here. Our top activities for this database, our top SQL queries, and so this can be a lot of insight. Right now, it's just very busy, and we're seeing a lot of activity from on this database. So we'll let that run. It's constantly updating per second or per in this 5-minute window. So cool. We'll let that run and jump back till it's done. So just jumping ahead, we've completed the benchmark here on the Graviton instance, and double check we're not hitting it with much load. Yep. So back to idle, 4% CPU usage on all of them. No more benchmarks running. And once we harvest the results from the logs, these are just the number of operations per minute is a good benchmark figure to focus on. And we see x86 gave us 11,700 number of operations per minute, and on the M5, and on the M6G we saw 12,200 on the Graviton instance. So as well, transactions per minute, that's 27,000 versus 28,000. And what we're seeing is a 4.6% difference between improvements on the Graviton2 instances. So this is a minor improvement. Yep, it's a good improvement. There's been no optimization or tuning or digging in and changing parameters here. This is the same benchmark run on both of them. And when we compare our hourly costs or our monthly costs, it's 11.9% lower costs on the Graviton instances, the M6G.large. And, for this extra 4.4% better performance, we're getting in the range of like 15 to 17% cost performance, better price performance increases here with just a few moments of, of work. So this is a great, win for just a very minimal amount of work, no extra tuning needed for these databases. And you can squeeze out, I'll show some other examples where you can squeeze out even more if you do some performance tuning. But this is just a straightforward jump right to the latest instance types. So yeah, perfect. So that's the quick demo here of jumping over to Graviton2 instances and benchmarking it. We recommend benchmarking with your own real workloads and see what your performance looks like. But yeah, happy to take some questions here and jump into some other performance graphs. Mm-hmm.
Yeah, that's a great demo, guys. We did have a few questions that came along in the chat there. I think the first one will go over to Mike because you were talking about the different instance types and memory optimization and things. So can you clarify what the difference is between memory intensive and memory optimized?
I would say, Ivan, do you have a good answer for that?
Yeah, we use them interchangeably, I would say. When your memory requirements are very high, that's where you must move up to the R6G or the X2G. Yeah, that would be the straightforward answer there. They're used interchangeably. We have a whole slew of products for in-memory performance, like memcached, for for Redis support or Elasticache support, but this is focusing on when your database requirements, like you get much better performance with much more memory. So some workloads do demand a lot more memory than than others. So yeah.
I think it may also be like the application that you run may be memory intensive, therefore it requires a memory optimized instance type. The actual, if you go and look at the EC2 instances page, which I'm going to drop a link to here in the chat in a second, it is memory optimized, where the workload that runs on there may be memory intensive. I think that's another way to also explain it based on how it was covered a little bit earlier. There was another question that came through the chat here is, are there any other hardware related differences, for example, clock speed or RAM megahertz, the actual clock speed itself, between the CPU and RAM for optimized instances besides the ratio of CPU cores and RAM? Are you guys able to answer that? Are you familiar?
Yeah, I could grab this one. So there are some differences there in clock speed, for example, but the biggest difference is the fact that each vCPU is a physical core. And that's really where you're seeing, as threads increase, as workload increases, you're not dealing with hyperthreading and the non-uniform memory access. So yes, there are improvements to clock speeds and newer memories, but the real bump here is the extra vCPUs, really physical cores you're getting the benefit of. So yeah. Just to, because we only tested this demo was only on one instance size and on one thread, right? The 50 threads. We had 50 virtual users created. If we actually look at the largest instance sizes, this is the M6G 16XL. We can see even better performance here. This is related to that we have the full cores, not virtualized cores, that not vCPUs there, or shared vCPUs. So what we're seeing on the left, right, as thread count goes up, 2,048 threads, the 16XL instance is giving us 81,000 versus 60,000 new orders per minute. This is another HammerDB benchmark that's been run, and as orders ramp up, you can see how we consume more threads and how effective Graviton2 is at higher thread counts, right? So this is a 35% performance increase, to 81,000 to 60,000, and this is one case where you're getting significant performance improvements as well at the very high end of databases. So on the right, this is very similar to what we saw. This is a much smaller, in the demo, a much smaller instance type, the smallest instance types. And here we're seeing, 17,000 versus like 14,800, 15,000, new orders per minute. So we're seeing closer to like 15% improvements, as we have 12 threads. And my workload was 50 threads. So just another, varying instance sizes matters, right? If we jump to the next slide here, we're actually looking at Aurora on MySQL. So very similar scenario, right? We're comparing the R6G.xlarge and the R5.xlarge. So these are the memory instance types here, right? More memory for the instances. And we're load testing again with HammerDB, looking at orders per minute. We're getting a 15%, 1.15x bump here as we increase to the 50 virtual users as we add more virtual users. And next slide, at the highest end scales here, this is looking at the R6G 16XL, right, as a Graviton instance in light blue. And with the direct previous generation instance comparison, the .16XL, there's a 1.5x increase once you go past 64 connections, right? That's those, and and if we compare with a much larger instance family, the instance type, the R5.24XL, which even has 96 vCPUs, you're seeing even still the R16XL is beating the instance type with way more vCPUs. So that's 96 vCPUs versus 64 vCPUs. So, significant improvements here. And this is running a 1,000 row in memory range scan with a nested 3-level nested loop. So, just driving it home, basically, your total cost of ownership drops with the Graviton2 instances. You're getting the highest performance for the instance families. If you're looking at the identical sizes between the instance, the lower costs immediately right there. Even if your workload doesn't see any improvements, as you should definitely test with your workloads. Even still, 11% lower cost is a significant improvement, and you can get up to 52% better price performance. With these differences here. So really, that's the best price performances within the instance families by moving to the Graviton2 instances. So yeah.
Awesome. Thanks, Aiden. That demo was fantastic, and I'm really excited to see folks starting to use these new Graviton instances. We have sort of a link page here for all the different links to start digging deeper into these topics, and looking forward to hearing from you guys. Clint, you want to wrap us up?
Yeah, totally. We did have another question pop through from Liquid Surya, and they are curious, what workloads see the most improvement by use of Graviton2?
I could take this. Yeah. So specifically with RDS and Aurora, the higher your thread usage, like the larger the as you increase the threads way past 64 threads, you're going to see a lot more benefits there. And in more broadly, generally what workloads see the best improvements. We covered web and gaming servers, right? That's a great use case for it. Mm-hmm. High performance computing can also benefit from this. In-memory caches, have significant improvements as well. So that's like your memcached and Redis workloads. Microservices are also a great workload for this. I would say database, like the managed services are going to be the most straightforward lift and the least amount of work to get started on. And some of your workloads may be easily, like they may already have ARM ARM editions, right, available, ARM architecture support off the bat. So that's really where minimal effort can be, expended for the maximum benefit, right? Managed services are a great place to start with, like the low-hanging fruit, mm-hmm. And that's why we chose RDS and Aurora to focus on today.
And if you wanted to learn more about Graviton2 in general for other things other than RDS, Aiden and I did another broadcast on Graviton2 and just sort of an overview, and we did some deep dive into some application-specific things. You can find it on our YouTube channel, and I'm sure we'll be doing more Graviton things in the future too. So please give us some feedback and let us know what you'd like to see next.
Perfect. So I think we're in the clear now to wrap things up for the day. I don't see any other questions that have came through the chat, so I think we're good to go there. So in quick closing here for everybody and the viewers online today, first of all, thanks so much for joining in on the Amazon Supports You Twitch stream. We appreciate it. Today we talked about Graviton2, provided some background, discussed the ease of adoption as well as operation, dove deep into Amazon RDS Aurora on Graviton, as well as some of the benefits that you're going to get there. And Aiden gave us a really good demo of migrating and benchmarking M5 to M6G Amazon RDS instances. If there are any questions not answered today, you can post your questions on repost.aws or email us any feedback to awssupportsyou@amazon.com. We want to hear from you, so tell us what you would like to see on the show also. Be sure to tune in next week where we're going to be discussing testing infrastructure reliability with Amazon Fault Injector Simulation. So thanks for joining us at Amazon Supports You, AWS Supports You, and happy cloud computing.